Hey guys, this is Ujjwal Kumar Sen and you're watching Ujjwal Kumar Sen English YouTube channel. So guys, as same we have done in previous videos, in this video also we're going to learn 20 more questions, right, in thermodynamics only, in TD, that is thermodynamics, right. So let's get started guys. So question number 161. We have given two identical metal blocks L and M, specific heat 0.4 kilojoule per kg Kelvin, each having a mass of 5 kg, are initially at 313 Kelvin. A reversible refrigerator, which is very important for this question, to solve this question. This clue is very important. Reversible refrigerator extracts heat from L block, that is block L, and rejects heat to block M until the temperature of block L reaches 293 Kelvin. The final temperature in Kelvin of block M is, so we have to find out final temperature of block M, right? So we know that, my dear, one formula, ds is equal to mcp natural log T2 by T1, but here we have two cases, therefore we can write the formula like this: ds is equal to mcp natural log T2 by T1, which is given, all the things given, right? mcp natural log Tf by T1. Now let's take common these two things, right? So mcp we got common, that is natural log T2 minus Tf, and at the denominator we have T1 square, because this T1 and this T1. Now my dear, because this is the case of reversible refrigerator, that means there is no change in entropy. So ds is equal to how much, my dear? 0, because entropy is constant in this case. Therefore what we can write, my dear, 0 is equal to mcp natural log T2 Tf by T1 square. Now send these two things to this side. So what we can write, basically, natural log T2 division T2 multiple Tf T1 square is equal to 0. Now use the concept of what, my dear? Log, right? So we're going to use concept of log. So from that, what we can write, basically, T2 multiple Tf division T1 square is equal to e to the power 0. And Tf we have to find out, so e to the power 0 multiple T1 square by T2. Here T2 is how much? 293. T1 is how much, my dear? T313. Now guys, do one thing, my dear, put the values and tell in the comment section what is the answer you are getting for this question. Question number 162. A closed system is one in which, so we know that what is the meaning of closed system, what is the function of closed system? Mass will not go outside, but energy can go outside already, or as well as we can get from outside to inside. So if we look at the options, we have option A, let's see, mass does not cross boundaries of the system, though energy may do so. So therefore option A is the correct answer, right? Question number 163. Kinetic theory of gases assumes that collisions between the molecules are. So my dear, here it is asking about assumptions of kinetic theory of gases. So in case of kinetic theory of gases, my dear, we have an assumption, that is what? Collisions taking place are perfectly elastic, not plastic, perfectly elastic. That means there is no loss of energy, no loss of energy. If it is perfectly elastic, that means there is no loss of energy. 164. Condition of perfect vacuum, that is absolute pressure, can be attained at, my dear, this is a one-liner question, right? So condition of perfect vacuum, that is absolute pressure, can be attained at minus 273.16 degree centigrade. But don't, my dear, mistake this with critical temperature of water, that is in plus and this one is in minus. So remember that. Most of the time students I have seen they confuse regarding this. Question number 165. An open system is one in which, so what is the definition, or what is the main function of what is the significance of open system, my dear? In case of open system, mass also can get go outside, energy also. That means there is conversion between system and surrounding, mass as well as energy. Now look at the option A, mass does not cross into, so automatically this is not the correct answer. Second, neither mass boundaries of the system. No, this is not also correct. And even that there is language problem in this option. Option C, both energy and mass cross the boundaries. Yes, this is the correct answer. Option C is the correct answer for this question. Question number 166. If a fluid expands suddenly into vacuum through an orifice of large dimension, then such a process is called, my dear, if there is expansion taking place against vacuum, that is known as what? Free expansion. In that case, there is no work done taking place. Question number 167. An ideal gas at 27 degrees centigrade is heated at constant pressure till its volume becomes 3 times the temperature of the gas, then will be. So my dear, here what we have given, pressure is constant. We have to consider the law, that is what? Charles law. According to this law, what we know, my dear, volume is directly proportional to temperature. So from this, what we can write, V1 upon V2 is equal to T1 division what? T2. We have to find out T2. Therefore, this equation can be written like this: T2 is equal to V1, T2 is equal to V2 by V1 multiple T1. So V2 is how much? 3V1 by V1 multiple T1, right? This cancel. 3 multiple T1, 27 plus 273, 300. So is equal to how much? 900. But this is Kelvin, not centigrade. It is asking about centigrade, right? So we have to do one thing. 900 subtract 273 is equal to how much? 627. That means option C is the correct answer for this question. Question number 168. Which of the following is not an extensive property? Now let's get understand this. What is an extensive property? The property which is depend on mass is known as what? Extensive property. Now look at, my dear, entropy, and just look at the entropy, my dear. Entropy is an extensive property because entropy is equal to what, my dear? dq by t, right? And in case of that, my dear, what we are getting basically, that is very, very important for us, right? dq is what, my dear? Extensive property because it is heat. It is extensive property. It is a part. I mean, what is heat basically? What is the function of it? What is the definition of it, right? It is the mode of energy transfer, and it is taking place because of temperature difference, right? So it is an extensive property. It is a part of it's kind of energy. You can low grade energy, you can say that. So my dear, क्या बोलेंगे इसमें? What we say, my dear, entropy is what? An extensive property. Enthalpy, it is what, my dear? Store energy, right? So it is what, my dear? Extensive property. Internal energy, also energy. So whenever we will see energy terms come, it is what, my dear? Extensive property, provided it is not specific, right? If there is specific, that means energy by mass. So energy mass, extensive by extensive will become intensive, right? Just like density. Density was, my dear? Mass, density, mass division volume. Mass is an extensive property, volume is an extensive property, so this will get cancelled. Therefore, among all the options we have given, option D is not an extensive property because density is an intensive property, right? And this is a very common question usually asked in the examination. Gibbs free energy is considered at which of the following conditions? So we have given 4 options: isothermal, isochoric, isobaric. So matter Gibbs free energy, what is the meaning of, what is the main definition of Gibbs free energy? What do you understand by Gibbs free energy? That you need to know. Maximum useful work can be obtained from the system is the it is the Gibbs free energy. It is the definition of Gibbs free energy, right? So here it can be taking place at constant temperature as well as constant pressure. That means option C is the correct answer for this question. Question number 170. On a pressure volume diagram, the process PV to the power n, C is equal to constant, as the value of n increases what will happen, right? And this is a very good question, and this question, based on this concept, I have seen couple of times they have asked question in ESC, even in SSCJ, even in PSUs, so you must know. So let's draw PV diagram, right? And this one like this, so it will be like this, okay? All right. So here n is equal to 0, here n is equal to 1, here n is equal to n, here n is equal to 1.4, here n is equal to infinity. As you can see, as we are increasing, getting closer to what? P axis. What is the meaning of P axis? That is y axis, right? Now When n is equal to 0, it is isobaric process. When n is equal to infinity, it is isochoric process. N is equal to 1, it is isothermal. N is equal to n, it is polytropic. N is equal to 1.4, isentropic or reversible adiabatic process. So you must remember, right? And one more thing, my dear, just look at the diagram, TS diagram for this case only, because that is also important. Question number 171. Work is considered to be a superior form energy as compared to heat, because what is the reason behind this? We know that work, my dear, is a superior energy. Why? I will tell you. Heat is not an superior energy, right? Because my reason is simple. We cannot convert complete heat into work. We cannot convert complete heat into work, but we can convert complete work into heat. That is why. Now option A, option C, let's read. While work can fully convert into heat, but heat cannot be fully converted into work. So therefore option C is the correct answer for this question. Question number 172. Non-quasi-static process is. So first understand what is the meaning of quasi-static process. Quasi means, my dear, almost, and static means stationary. So almost stationary process. Non-quasi-static means, it is not almost stationary, right? So it can be possible only in case of one process. That is what, my dear, free expansion, because it cannot be possible in case of free expansion, right? Because free expansion cannot be get reversed, right? Because whenever we are going against vacuum, there is no work done taking place, right? And this cannot be even, free expansion cannot even reversible process. It is an irreversible process. Now guys, let's come to the question 173. In isothermal expansion, work done by gas depends upon. My dear, when we're looking at isothermal expansion, right? So it can be happen, just look at the diagram of PV diagram of what, my dear, this is expansion 1 to 2 we are going, right? And the diagram we are getting from Carnot cycle, right? Carnot cycle, right? And in case of free expansion, my dear, I mean, work done by gas depends upon which factor. So for that we have to write the formula for work done, that is natural log C natural log V2 by V1. C means how much, what is a C? C is PV, that could be P1 V1 or can be also P2 V2, and C natural log P1 by P2. Here I am giving you a trick to remember this formula. Just tell me, my dear, what we got in English alphabet first, that is P, that is why it is P1 by P2. Next we got V, that is why it is V2 by V1. We got P, that is why P1 by P2. Next we got V, that is why V2 by V1. So if you get confused in examination, you will not face such problem, right? And my dear, this formula is very, very important. Even in GATE I have seen 5-6 times they have asked question from based on this formula, and people get confused because of this. What will happen, V2 by V1 or P1 by P2? And I told you the concept, remember it, right? Now guys, 174. Which of the following parameters remains constant during ideal throttling process? This is very, very important, right? Which of the following parameters remains constant during ideal throttling process? Pressure, temperature, volume, enthalpy. My dear, in case of throttling process, right, what is the name, or what is the other name of throttling process? It is an isenthalpic process. What is the meaning of isenthalpic process? That enthalpy is equal to constant. That means option D is the correct answer. Even in case of throttling process, my dear, pressure decreases. From where we got this concept? Whenever we study about VCRS, vapor compression refrigeration system, or VCRC, both are same, vapor compression refrigeration cycle, right? So from that, if you'll understand, if you'll read properly, if you'll understand thoroughly the concept of VCRS, then you can easily understand about that. Question number 175. When a gas flows through a very long pipe of uniform cross section, the flow is approximately. My dear, whenever any gas is flowing through a long pipe, in that case there would be temperature will be constant. That means that will be isothermal process. One liner, my dear, remember it. Question number 176. Isothermal compression through most efficient, but it is not practically possible. See, there are two processes. About these processes you must know which one is slower and which one is fastest. The slower one is isothermal, and it is a slower process, so practically we cannot get slower process because it is not possible, right? The same thing happening with Carnot cycle. It is what, my dear, it is combination of isothermal and adiabatic. Once you have to go slow, then you have to go fast if you wanted to make this theoretical cycle into practical. Why Carnot cycle is still, my dear, a non-practical or theoretical cycle? Because it is not possible. We cannot make it slower and then faster, because adiabatic is fastest and isothermal is slowest. Therefore, here, my dear, option D is the correct answer. Question number 177. Change in enthalpy of a system is the heat supplied at. My dear, change in enthalpy of a system is supplied at what, at what condition heat will be supplied. That for that, my dear, we need to write the formula. That is what? dH is equal to mCp dt. What is the meaning of Cp, my dear? Constant pressure. Therefore, it is isobaric process, but again it is simple. Option A is the correct answer for this question. Question number 178. For a closed system, difference between heat added to the system and work done by the gas is equal to change in. So, my dear, for this we have to write the formula of first law of thermodynamics. That is what? dq is equal to du, right, plus dw. Now, my dear, du is equal to what? dq minus dw. Therefore, because of this, what is changing, my dear? du is changing. So, change in internal energy. Question number 179. In an isothermal process, the internal energy of gas molecules. So, my dear, what is happening in case of isothermal process? Let's write. We know that internal energy du is equal to what? mCv dt. Here I am sharing the trick to remember whether it is mCv or mCp dt, because what is next? After u we are getting v. Therefore, in case of du, mCv dt, right? After, in the English alphabet, we are getting v after u, right? Therefore, we'll write, my dear, du is equal to mCv dt. So, in that case, what is happening? If isothermal process, that means dt is equal to 0, right? So, what will happen, my dear? du is equal to 0. That means what? Internal energy would be constant, because change in internal energy equal to 0. Therefore, option C is the correct answer for this question. Question number 180. The more effective way of increasing efficiency of Carnot engine is to. So, for this we have to write the formula T1 minus T2 by T1. Now, look at this, my dear. Look at this. If, my dear, the value of this term will be more, that means efficiency will increase, if provided T1 is constant. If when the value of T1 minus T2 will be more, when, my dear, the condition will be possible if T2 will be lowered. That means sink temperature will be less. In that case, my dear, efficiency will increase, right? Because this term will, the value of T1 minus T2 will increase. That means efficiency will increase. So, answer for this question was decrease the lower temperature. That means option D is the correct answer for this question. Thank you very much guys for watching. My dear, I will tell you one thing. We have launched NLC test series, right? For that, for non-tech as well as tech, right? In the non-tech we have 65 plus test, and tech we have 10 full length test. So check the description for getting the test series, and I want to see you soon in my next session. Bye bye.